Good morning, guys. It's noon. Let's get going. Thank you for coming, for joining us today. My name is Oscar Garcia, and today I am going to be presenting about data modeling for building out a data warehouse. So today's focus will be around the areas where we need to consume data, use the data lakes for staging and moving the data into a data warehouse. So we go in step by step to show you guys how that can be done. Okay, so let's get started. First, guys, a few housekeeping tips here. Please use the chat for conversation, Q&A for questions that we can actually track and answer as we move, as we make progress in the presentation. Please enjoy the presentation, follow the GitHub project, follow the YouTube channel. Please give us a star, give us a like. That helps us keep building out the content and helps us keep growing this information. So thank you again, and let's get going. Thank you for joining us. All right, so let's start with data engineering. So all these conversations, these presentations about data engineering process, just to give us a little bit of background, what data engineering process is really just a series of steps that we follow through in order to complete or build out a project. So whenever we start a new data engineering project, we have to go into a discovery phase. We got to do some planning and design. We got to work on data pipeline and orchestration, data warehousing, data analysis. There's also data streaming, another one of the subjects that we are going to be covering later. Today, our focus is on the data modeling and the data warehouse side of things. So today, we are going to basically first give a background on operational data, and then move forward into data lakes, data warehouse, talk about data schema and data modeling, what that means, what is it, why do we need to do it. We talk about data strategy and data optimization, so our solution can actually deliver value, orchestration and operation as well, because that is key in order for us to keep building out the solutions and keep supporting it in production environments. As I talked about before, everything that you will see here today is in a GitHub project. All the source code, all the comments, and some of the feedbacks about how to run this project is there. So don't feel, if you feel like there's areas that you don't understand, or maybe you feel I'm going too fast because you don't have all the background, visit the GitHub project, and you can take more time to read it, to look at it, and understand all the different steps. Let's start first with the operational data. What is operational data? And I'm pretty sure most of us here understand these concepts, right? So operational data is really an online transaction processing system, right? So this is basically the data that's generated by applications, and is stored on maybe transactional relational databases like SQL Server, or NoSQL databases like Cosmos DB, Firebase, and some others. This is really the data that, as our applications are running, it is stored in a database. So it is important for us to be able to support transactions using this relational database or NoSQL database, right? And it's meant for us to track the transactions, track the activities, and it's very good for small queries, for data lookup content, and things like that. But it's really not good for reporting and analytical systems, what we call an OLAP, which is an online analytical processing system. It's not really good for large queries. Sure, if you work on SQL Server, SQLite, and you start running reporting system against that, and you're doing massive amounts of queries and data, then you can notice how the system starts to struggle. So it's really not meant for a centralized big data system. So then how do we deal with that, right? How do we move this operational data, historical data, of all these transactions into a system where we can actually use and query and be able to visualize all information. So for that, the next step is that we need to create a data lake, right? So this is now moving the operational data into staging analytical platform, which is really a data lake, right? Which is blob storage designed for big data scenarios. Really, the primary function of the data lake is to store the data in its raw format without any transformation. So as we import data from maybe a database or CSV files or JSON files from an API, even XML files, this data is just stored there. So you picture a big drive, right, where you were storing all these files, right? And this is really a good location for us to store our data and build a data pipeline that can actually move this data from data sources into staging, and later on from staging into our data warehouse, as we are about to see soon. So some of the features is to store raw data, JSON, XML, CSV. Is really a low cost storage system. And it's also not designed for querying and data analysis. You definitely can read and make queries. There are systems out there that will enable you to read data from a data lake, but really it's really not optimized, right? Because of it's really it could be unstructured data that is difficult to query. So it is used as external tables by most systems, including a data warehouse. So as we have the data in our data lakes, our next step is to move it into an analytical data platform, right? So in this case, a data warehouse, which is a centralized storage system that stores the integrated data from multiple sources, right? And the whole idea is to create this system where we can actually now run our analytics, our visualizations, and be able to query the data, big data, with lower operational costs than transaction databases, but of course definitely has a higher cost than a data lake. So a data warehouse really gives us the ability to store historical data, massive data, in a relational structure, relational tables with optimized schema. It definitely provides SQL support. At this point, we can actually enable do the queries, select statements and what have you, to be able to fetch the data and be able to create reports and dashboards and visualizations. It integrates with external resources like data lakes, right? So basically, as the data is imported into a data lake, data warehouse can actually use that data lake and query that data and query the information there, and it will just look like an external table. Definitely not optimized, but it will just give us the ability to read that information. So the storage is more expensive, and there's also policies to archive the data. As the data, you can't have the data for 10 years, for example, right? There's going to be some archival policies that will say data that is older than so many years can be moved back into a data lake. So like blob storage for archiving information, which is going to be a very low cost. Okay. For those that just joined us, thank you for joining us, and please use the chat if you have any questions. So as I go through the presentation, I'll go back to the Q&A. The Q&A to ask the questions, and I'll try to answer those questions. All right. So moving forward with the data warehouse, what's key now is how do we go to building this data warehouse, right? There's really two main areas, right? The design and the implementation areas of the process, right? So in the design phase, that's when we talk about what is the system we're going to use. Are we going to use some kind of BigQuery, Redshift? So these are data warehouse systems, right? Or are we using some other tools, right? What is the schema model that we're going to use? What is the logical data models that we're going to build? What is the technology stack that we're going to be using here? Is that, do we use SQL? Do we use some kind of Python code to be able to build this out? And also we need to define the frameworks and the tools that we need to use in order to build this solution, right? In the implementation phases now is the hands-on process, right? That's when we focus on picking up our logical data models and now making it into a functional system, right? We create the dimension tables, the fact tables. We do data transformations. We do data cleaning, integration, and so on, right? This enables us. This is really the hands-on. This is the coding part of things, right? But fundamentally, we definitely need to be able to understand what we're building, how we're going to build it, and what are the tools that we are going to be using to build this solution. So this, when it comes to design and the schema modeling, this is where we actually now need to start thinking, right? So we have all this raw data in a data lake, and it doesn't have any structure at all, right? It's just really some maybe flat CSV. So we need to start understanding what we need to do and how we're going to do it. So one of the first things we got to do is we got to start defining what the schema for this data warehouse system is, right? And star schema is one of the popular ones. It really just revolves around building out a fact table that's connected to multiple dimension tables, right? Via foreign keys, right? So it's really a relational kind of system, right? But it's not that deep related system, or doesn't have that much it is not highly normalized in every sense, right? Like you would do a relational database, because it's really focused on inquiry performance and data model simplicity. That's why star schema is very popular, right? So it's not building out all this deep relationships or foreign key relationships. But for those systems or those cases where you still need to build out such normalization, so there is a snowflake schema, which is an enhanced star schema, but enables us to create more dimension tables, more foreign keys associations, right? So and the idea here is to the complexity of the queries is not a concern, but it's really mostly targeting a storage, right? So the higher the complexity of the relationships, the more storage you will have. But of course, there will be query performance issues because you start doing a lot more things. In our case, we're focusing on using star schema for our project because our data is really not that complex. So now that we understand the schema definition that we are going to be using, now we need to start thinking about data modeling, right? So for data modeling, this is really the foundation of the data warehouse. This is really how we're going to build this, right? So we start by looking at the data, right? So we look at a CSV file that's there, and we kind of see how it's just really has no relationships. It's just one flat line. You see a lot of repeated code, and the columns are probably not structured together. They're separated, like the date and time are separated. So we want to improve this, right? So we want to be able to look at this and create our logical models based on our data requirements and understand that we need to build a relationship, right? So we need to separate the stations and the booth information from our sort of our log data or a fact data, right? So once we do that and we create our logical models, then the next step is to actually now convert this into a physical model, right? And in this case, we start using data definition language scripts, which is like create table, create views, create store procedures, and so on, right? This is what enables us now to create the physical structure of our database or the physical model, and with the focus on technical requirements, right? So and technical requirements are performance requirements, data storage requirements, availability requirements. And this takes us to some of the technical requirements that we just talked about, which is data optimization to deliver performance. So once we understand the table structures that we need, the relationships, the foreign keys, we need to start looking at performance, right? How do we optimize the queries? How do we deliver performance, right? So usually there's two key techniques for this, which is data partitioning, right? And data clustering. So data partitioning is where we segment the data into smaller buckets, right? Based on a particular column. It could be the date field. It could be some other field that you think is relevant to your information. And you got to remember, this is a cloud-based data warehouse where there is a massive redundancy, and there is also clusters, right? And different sort of disks allocated, but this is mostly for blob storage, not physical disks. But so it is important to be able to define data partitioning so we can actually segment the data in that way. And in addition to that, we do data clustering. So the clustering enables us to now grab each of these partitions and be able to cluster them by a particular column. So in this case, let's use the station ID as you see here on the syntax on the code that you see there. Basically, what it's doing there is saying, I want to create this table, materialize this table in such a way that I want to partition by the created date. And I also want to be able to cluster by station ID. And this is key in our case, because this is what we use to be able to, for example, select by a station, group by a station, perhaps sort by a station, right? So this is key for us. So clustering is very important. And what you see here, there's a comment there, Jinja template syntax. This is very important. So this is a sort of a template syntax that we use to be able to model the data and be able to create our tables and build our data warehouse. And we are going to see this more in detail once we start looking at the code. So what is the plan here? How do we do this data transformation, and what is this incremental strategy? So we just saw before that there is some file out there, CSV files, right? And these files are located they are in a data lake. So for our process, really, what we need to do is we need to run our data transformation process, right? And we need to be able to understand how to extract the data, how to clean it, how to load it, how to do data type casting, right? So it's just, so for example, if you remember previously, we had a day and time. Maybe we want to just create a daytime field and put together those two pieces of information, right? So, but data transformation and the process to clean up the data, use naming conventions, and be able to load the data in an incremental strategy is key. So basically what that means, incremental strategy, that means as data continue to grow, right? So for example, the data from last week, the data from yesterday, and the data for tomorrow, these are incremental delta pieces of information that the data pipeline is gonna import into the data lake, and our process is gonna pick it up and build out the system, right? Build out the different dimensions, build out the data for the fact table. And the way that works is, if you look at this data lineage, it's really the workflow that enables us to see the process, to visualize the process. So what this really, the way this reads is that as we have a external source, we go and start creating logical models, right? To start doing, for example, separating what is in the station, separating what is a booth, right? So everything that's prefix STG really means staging or logical models, right? And then what that is really, we're just staging that data, understanding this is the data typecast we need. This is how we're going to separate every record there. And then we're going to start building our dimension table. So from that staging logical model, we build out our dimension booth, our dimension station. And ultimately, off of all this data, we get the fact table, the staging turnstile. And off of that, we build our fact table, right? And that's really what now has the physical table with the dimension tables associated with. So keep track of that visual. That's important, because this is the process we're gonna take to build this system. And definitely, we can never forget is key components of this is the orchestration and operations. For orchestration is really just how do we automate this? How do we deploy new changes? How do we consume new data? What are the tools we need to use? How do we manage that reporting, right? So definitely tools like GitHub for CI/CD, continuous integration, continuous delivery. It's important to constantly keep building this out for new data, documentation to be able to understand all the data objects that are in the data warehouse, be able to understand data governance. All that's key, right? So what this means really is always look for those tools. If you're using any kind of tools platform that enables you to be able to maintain this kind of requirements, right? As scheduling, automation, monitor, and notification, right? Of course, if something fails, you want to be notified. You want the team, the site reliability team, to be able to be notified so they can work on the issue or communicate the issue to the development team so they can fix the problem. As a summary, these are the technologies that we are going to be looking at. And these are the resources for the GitHub project. And basically some of the articles that I've written around this area. And as I mentioned before, the GitHub project, the YouTube channel. There's also a book that goes into more details about all of this, and I pasted all those links on the chat, so just take a look. But going back, let's look at some code now. So so just quickly, the first thing is you go to the GitHub project, right? Just to give you an overview, and let me blow this up a little bit just to make sure you can read it. Okay, so the GitHub project. So please give it a like. That helps. The GitHub project gives you more details, right? It takes us through a whole step of discovery, design and planning, orchestration, data warehouse, and so on. So today, looking at step 4, data warehouse. So that's where you want to be. But just to give you some background, right? So the background is that we are building out a system where we can actually build out a geofence and understand how to track people, so people can be communicated with some kind of advertisement, right? And ultimately, the goal is to build out a dashboard like this, right? So we need to build a data warehouse to support this dashboard. This is where all the information comes in, and this dashboard is available. Theirs is available here, right? And the tool we use for this dashboard is really something called Looker Studio, right? So if you're familiar with visualization tools, there's Looker Studio, there is Power BI, there is Tableau. Those are great enterprise level tools that can enable us to build visualizations of high quality, right? So as this is loading, you can see, so this is a live system. This is that looking at the data warehouse, and you can see there is filtering by day, right? Filtering by station name. So this gives us the idea, right, what we need to do. Of course, this is the final product, but I just want you to have an idea, why are we going through this process, so we understand that why are we taking the steps we need to take, right? So what you want to do eventually, once we're done here, you just want to focus on step 4, the data warehouse. It's going to give you all the instructions on how to build this out, right? So don't worry if you think I'm going too fast. You have all the information here. But let me just jump into Visual Studio Code, and let's take a look at the code here, okay? All right. So similar to the GitHub project, you have all the structure here, right? So you have all the different steps with all the different code in all the files. So the first thing really here to do is we have files in the data lake, right? So what do we have? Okay, so let's take a look at what we have, right? So we can import, by the way, this is Jupyter Notebooks. So this is an interactive tool that enables us to query using Python. We can query our data, right? So here, what I'm doing here is I'm saying I'm going to connect to a GCS bucket on Google Cloud, and I'm going to say I want to look at this bucket from our data lake, and I want to be able to look at this particular file and see what the data looks like, right? So one thing I can do, I can query through the command line. I can query those files, but command line is a little slow, so we won't do it like that. But it exists. The CLI for this exists. But what you want to do is use an API, right? So using the API, we can come in and run this, And basically what this is going to do is based on that configuration and my credentials, right, that are hidden within the system, is going to connect to Google Cloud. It's going to get authorized, and then we're going to have access to the files. So what we can see here is that we have all this CSV compressed, right, files. And this is what that data, the data we were looking at, right, with all the different information, right? So what we can do here, and we can see here, if I can hide this properly, the last file we got is from February. So from February the 3rd, and it's about 2.7 megabytes of information, right? So one thing that you read the entire project, you will look at the, when it comes to the discovery process, you will see that some of the system requirements for this integration is this data is only available on Saturdays, for example, right? So this is a batch process, and the new batch is available just Saturday. So that's where they put this data there, because this is massive amounts of data. As you can see, if we go back really quick, right? So if you look at that, we're talking about terabytes of transactions, right? This is really the amount of data that this thing is supporting, because this is really for the subway in New York, which is used by millions of people every day. Okay, so bear that in mind. So this is a big data scenario where we actually need to support massive amounts of information. So how do you view the data? So definitely what you do is you can just quickly create a based on our variables that we define. We can define the bucket, we define path, and we just basically query this data, and you just run that cell. And what's going to happen is you run that cell, right? It's just going to show us that it's trying to query that data there, that file within this path. It's going to open up that file, and then it's going to show us the data, right? And we saw this data before, but I just wanted to show you what it looks like from the standpoint of what's on the data lake. So, and we see the last data that we talked about, I think was on the 3rd. So let's do something really quick. While we talk about this, we're going to run the pipeline, and we're going to get the next week. Okay, so this file is located on step 3 for the orchestration. And this command here, we can run it locally. And we can just basically, if we do this, what it will do is it will just go get the next data. So we're going to leave it running while I go deeper into the presentation, because it's just going to go get data, download the file, process the file, and send it into our data lake on Google Cloud. So this process is a little slow because, I'm just running this locally. So you will see some of the metadata coming in saying, hey, look, I'm creating a new flow. I'm logging the information that I'm doing, and it's just tracking that data. So it's running. So while that's running, let's keep going here, right? So, all right, so we can see the data, and we understand our data. Our data is definitely, it's just a flat file with some data that we need to break down. We need to understand the dimension of this file. We need to break down the data that we need. So for example, day and time, we don't want to separate it like that. We want to create a daytime field and put them together, and we want to be able to get the measures like entries and exits, right? Those are the amount of data that we're talking about, right? So what this is reading is saying that on January the 6th, for the station 59th Street at 3 p.m., there were 105,000 entries and 76,000 exits, right? And 3 o'clock is really not a peak time, right? It's just a slow times. Imagine peak times, we're talking about millions. But the point is that these numbers are huge. Okay, so how do we go to the next step, right? Because now we have this file. We need to build this out, put it into a data warehouse, take it from the data lake, and add it to our data warehouse so we can create our visualizations. Right, so we're going to be using BigQuery for our data warehouse in Google Cloud. So the first thing we want to do is understand how BigQuery works a little bit. It really works mostly like any relational system, right? So you have a lot of support for SQL queries, but it's optimized for big data scenarios, right? So one of the things you want to do here is you really want to import some of the Google Cloud libraries, APIs, right? And you want to give it a project and a dataset name. right? That's not the way this system works. You, depending on what system you're using, you have to kind of detail the information. Like if it's a Redshift data warehouse and so on, you need to understand how to connect to it. The point here is you can use an API here, be able to build a client. So here we're going to build the client reference, right? We're going to get a reference of the context of the data set, and we're going to be able, and we're going to define a function here, a quick function to run our queries, right? So I think I did not update this, but you can run this cell all the time. So this is Jupyter Notebook. Always run your cells in frequency, right? Just like an execution of line by line, you need to define your projects, you need to run your cells, and you'll be able to know that the context now for the client and the data set reference is defined, right? So now we can move in and do some queries here, right? So a quick query will be to actually just go and say, what's in the data lake, right? So this is really a definition for an external table. And what it's doing is really looking at the data. The way this works is that what you can give it like an expression to say, define an external table with these patterns. And the pattern for that was this, right? The pattern for that was that we want to pick up all the files in this bucket that have this structure, CSVGC, for example, right? That's the pattern. So what it does, it actually on the fly puts all these files together so we can query them as a table, right? That's essentially what that does. So when you run this, right, when you run this, it really goes out there. It runs a query through the API, shows us the query we ran, right? So give us select data from that external table and limit this to 100, right? We don't want to take a lot of stuff. So we're taking like top 100. Right. So here's the same data, right? So this is the same data now coming from the perspective of the data warehouse, looking at the data lake, right? So it's your vital integration point at that point, right? So now we know that data warehouse has visibility of this data, this external table, so it can process the data. By the way, so we know here that this system, if you look below, the flow just ended, so it completed and imported a new file. So what that means is if I go back to the data lake and my last file was from the 3rd of February, if I rerun this, right, what that's going to do, that should give me a new file, right? So yes, and it does. So it gives me now February the 10th. So there's a new file that we have here, right? And if we look at our BigQuery, it tells us, right, that you can run this also just quickly as you run the definitions. You can run all the tables that are there. You can query what the tables look like, what the schema definition is of that table, like the columns and the fields and the amount of data that's in there. And so you can query all the metadata for the tables, right? So, which is important to understand the health of your system. But at the same time, the thing that we wanted to focus on right now is we want to be able to kind of understand the different dimension tables, right? So we can run also, hey, show me what the dimension for station looks like. You can run that query and you can see the station name, station ID, and I'll show you how to build all this out. I'm just really now showing you from the standpoint of what does the warehouse looks like, right? So so here, this is the important one. So we just did a data import here, right? And we noticed that we imported data up to the 10th. And by reading the data warehouse here before, it told us that we only had data until the 2nd of February. All right, so now we're gonna have to import a new data set into our data warehouse. So let's keep an eye on this, right? So right now the latest is the 2nd. So once we run our process again, we'll be able to see how this incremental strategy kicks in. Okay, so let's keep going. So right, and then you can do additional queries to kind of query the fact tables, see the amount of data that we have, right, and so on. So you can run all these queries and kind of see the data and the structure, and it's there. So it's a file called BigQuery that is also on GitHub. All right, so how do we build this, right? So how do we go about to build this, which is the important part. So when you go to this project, right? You're gonna have a structure like this, and all of this is on the GitHub project, all the information. The key here is to look at the models folder, right? And in the models folder, just similar to how we were prefixing with STG for staging, we build our models, right? So what we're saying is, hey, I want to build a model for example, for my turnstile back table, right? If we take a look at that, we can see the strategy here, right? So what we're saying is, materialize this as a view and give me this information to build out. What this is essentially doing is saying, create a view, which is sort of a logical model to be able to understand how to build this out, right? And how to do some level of transformation, some level of typecasting, and so on, right? This is where you will do some of this data modeling using SQL. That's the power of this approach, right? Where you can actually do this stuff and keep it as and build it as code, right? Using SQL. And then you will have some of the definitions here. If you look at the schema for the station, then you will see how this is defined, right? See, you have some of the description, you have some of the testing scenarios, and so on. So let's look, for example, turnstile, which is more complex. Here we actually see the primary key definitions, then the relationships, right, for the different fields, the descriptions, and so on. So this gives you like metadata for what that logical model looks like. And it's sort of documenting and building it out at the same time. But that's only the staging. And if you remember, we have a lineage, and the lineage tells us build your logical models and then build your physical models. Okay, so just keep track of that. So how do we do that? So now that we have our logical staging models in the same folder, we can go to something called core. And core is really where we have our physical model definition. So for example, let's look really quick at the fact table. And in the fact table now, we can see that we are using a incremental strategy to materialize this table. And we want to partition by these fields, and we want to cluster by that. And with this, what this is doing is really saying, create me a table with this information, right? And the information is here. So how do we build this? We use our logical model, right, as reference to be able to get this and create a common table expression to be able to kind of materialize the information the way we want it, right? And then we associate it to our dimension tables for the foreign key expressions, right? So, and then we do create this sort of view that basically when we run this, it actually creates the actual table. And then what it will also do, create some temporary tables. So when there's a new delta change, a new data import, it creates some kind of temporary process to be able to do a data merge, right? So it will say, hey, data that's on the data lake that's not present on my data warehouse, let's do a merge, right? So it creates that, right? So so the way you do is you start building this stuff out like that, and you also have your schema definitions, right, for the physical models. And now here, this starts getting a little bit more detail how you want to run this, how do you want to validate this, you know, how to do relationships, right? So it gives you all this metadata that is key to be able to build your data warehouse using code, right? Which is important for the automation part of this. And another thing that you want to see, so we have this code, right? So this is kind of a SQL-like code, but it's really not truly SQL. We see some brackets here, and we see the reference, right? So the way this gets built out, right, as we build this is, if you look at the target folder, right? If you look at the target folder, you will see when it gets compiled, you can see the definitions for the different for what it actually looks like, what gets deployed, right? What gets deployed on the data warehouse. So target is really if you want to see the true SQL that gets built. But so those are the areas where you want to go. You want to take a look at that, and you want to be able to go step by step and look at how to build this. And you have a README file here on DBT file that goes and takes you through the steps of what the commands are, and so on to build this, right? So you have all the different commands and show you how to go to about to build this. Of course, we follow a workflow to do that, and we automate this. But let's take a look at that. So once we have this code and we know, we go into this data modeling, right, process. So the data modeling process is really, we're using dbt, which is a cloud engine, to be able to use SQL, pure SQL, to be able to build our data warehouse. Very powerful, very, very popular in enterprise solutions. So it is really, really very powerful. You will see that the level of performance that this thing has is incredible. So the lineage, as I said before, this is really what we execute and we process. So part of the process is you got to be always to keep updating your dependencies, your versions, right? So you can run all this through the notebooks. And what you will notice here, I'm using the notebook because it has document, but these are really command lines instructions, right? But what you could do is, for example, like, how do we build this, right? So we say, hey, build this model, which is the dimension table for station. And what it will do is, when you do a build, it actually executes the file, executes the metadata, executes all the tests that are associated. And you will see here, you will see all the metadata that is exploding, saying, hey, look, I'm building this out, I'm merging these records, I'm doing all this data. So you will see all the metadata that enables us to track that it is performing or it's not. So we do the same thing with booth, and ultimately we do the same thing we can run all the tests. So when we run all the tests, we can see all the tests that are included, validating foreign keys, validating unique keys, validating data for required fields that you don't have no data, and so on. So you have all this stuff. So this is more of a code-driven or code-centric type approach of building out the solution. So, but ultimately, so you notice back and said, look, we have some data that we just input, right? So let's put that data back, because we noticed is that we were only running up to February the 2nd. So let's import, let's build out. So the run command is done usually for production environments where you actually want to keep that integration ongoing, right? So where you want to, in a live environment, you want to keep importing data. So it's part of that data pipeline process where you actually keep pumping new data or the delta changes, right? So this is going out there and it's saying, okay, let me just run that model, see what data is new in the data lake. Let me build out the different structures that we need. And it says, okay, so I found this. Let me go ahead and start running this. Okay, I'm going to start pumping data, new data that I don't find in my data warehouse. So what it just did is, it just said that it merged 250,000 rows. So the file we just imported had 250,000, right? It actually loaded up to 435 megs of data in about 7 seconds. Okay, imagine doing that with Python. If you were to be building this with Python, it'll take a lot longer, or with .NET or what have you. But this, it just ran that file, it just imported that file, and we can now go back to our data warehouse and query and actually look at what is the latest data that we have. So if you remember, it was on February the 2nd. Now we can run this again, right? And this will give us the new data. So now it goes to the 9th of February, because it's 1 day before, right? So the batch is available the next day after the cutoff day. So we just imported a whole week of data in this process. So please just go back to this project. It gives you all the information. You can look at the dashboard. You will see the new data being refreshed here. This one's taking a little longer to run. Let me see if but you will see how the terabytes of data now have increased because we just pumped a lot more data, right? So you will see that. So you see the slight increment there. But so you have all the steps here to process this, how to build it, how to install dependencies, how to follow the code. You have all the instructions here. So please take a look at here. You have the project tree structure definitions, what I just covered, target, core, staging, and so on, the lineage, all these commands. You can take a look at this, follow this, and this should be able to help us. But I think we reached to, yes, we finished. So thank you guys. Any quick questions? Not see any. Oh, I think it was not enabled. But anyway, so let me just take a look really quick. Okay, we're good. Okay, guys, let me look at the chat. Any? Yes. Your question, if you can. I do want to thank you. I know we ran over. I think we're 1 minute over, but thanks everyone. If you want to stick around, we can have a couple more minutes for Q&A. Yes, please. I think there is no direct enable right now. That's something I'm working on with the platform to enable be able to provide you guys with that. So, but let me see if I can do it right now. Let me see. No, I don't have the ability so far. But anyways, any questions? Feel free to use the chat for it or Q&A. And I want to thank you all for joining me today. While we get any questions, but just keep following that project. We keep growing it. Keep following the YouTube videos. I'm going to, once this is being recorded, once this is done, we'll be able to publish this. I'll send you an email through the chapter for you to follow, look at it, and review everything that we talked about. Okay. Again, thank you guys. Appreciate it. Any questions? Yes, if you have it, please go ahead. If you have anybody that has any question, just please write it down. Sorry, I can't right now enable the mic directly so far. I need to get that feature set up for my for this platform. All right, so we have a question. So so the question is, in terms of cost, which user is the one that runs these queries on BigQuery? So usually, because we need to build, the solution really is to build something like this, right? Something like visualizations like that. Usually the data analysis team is the one that's running all these queries, right? So the data analysis team is the one that's getting all this data, doing their visualization, building their charts, and kind of feeding this to maybe a machine learning model to be able to get the data and do some kind of predictions. But it's usually the data analysis team. This is not one thing that, for example, in many industries, a lot of people just jump into it to query. You can do that. I mean, it's very powerful. But the more queries, these cloud systems are based on how much data and queries you're running, right? So usually the data analysis team builds the visualization so you can actually give that to the business teams. If you use this code for testing, then you have your development environment, right? So your development environment is where you're going to have your data, your own copy of your data warehouse to build this. So you will be able to do what you want, to build your models and everything else. As you are good and you commit your changes to GitHub, for example, then the DevOps team needs it to be able to build this, automate the build and deployment of your queries into production environments. So remember, this is you can't be building on production environments, right? You have to use your development environment so it can get upgraded. Yes, so what you do is, as part of the process here, when you go into your connecting to your data warehouse, definitely as you set up your project, let me see, as you set up your project, you have your own account, right? So you will have access to this project and data set. You will have a service account or a user account, depending on how you want to do it. For development, it's usually a user account because it's you. And what you're going to have is you're going to have permissions to be able to do that. So how do you do that? So if you take a look at this project, you will have in the wiki and also in the discovery phase in cloud infrastructure how to set up your accounts. It tells you how to go through the process, and this is specific to the data to the cloud provider, right? The cloud provider will tell you, like Azure will tell you how to do is and so on. But you have configuration here, for example, how to create a Google account, right? So, and it will just show you how to create a Google account, right? Oh, it looks like the broken link now. So I'll take a look at that, at those things. But oh no, this is the Google account that you can create as a developer, definitely. And then it tells you how to create the service account, right? So this is the area where you create a Google account, service account, and then you give the roles, right? So you can do BigQuery admin and so on. So you have all the configuration. So important to follow all the steps so we understand clearly how to build the data warehouse. For example, this data warehouse, if you look at the cloud infrastructure, is built using Terraform, right? So if you look at Terraform, this is how we build and deploy this. And that presentation on design and planning gives you how do we go about to do that and build the BigQuery, the data lake, the VMs, and so on. Okay. It is massive, right? In the sense of there's a lot of concepts, a lot of stuff. There's a lot of cloud engineering, data engineering, development, and so on. So, but stay tuned, guys. Coming up with more. There's a data visualization, data analysis presentation. There is data streaming presentations coming up. So stay tuned, and thank you for the time. And I hope you enjoy this presentation as much as I did presenting it to you guys. Thank you and have a good rest of your day. Thanks a lot.